The R-22 from Robinson Helicopter Company is known for its compact design, low operating costs, and high reliability. Equipped with a Lycoming O360 J2A piston engine, 131 horsepower, air-cooled system, stable operation even in harsh conditions, simple engine design, fuel economy, the two main rotors are made of ultralight and durable aluminum alloy. The main rotor diameter is 7.67 m, helping the helicopter to be stable when flying at low speeds. The hydraulic rotor control system reduces vibration and increases flight performance. The two-blade tail rotor helps to balance the rotation force. The fuselage is made of aluminum alloy and stainless steel, reinforced with fiberglass in some parts, designed with simple aerodynamics, redesigned with an empty weight of 400 kg. The steering system with mechanical control mechanisms, cyclic, collective, and pedal, helps the pilot control the flight direction, altitude, and speed. The cockpit is a two-seat cabin with a basic control panel, including an altimeter, speedometer, and an optional GPS navigation system. The ventilation and soundproofing system provides comfort for the pilot. The fuel tank has a capacity of 80 liters, allowing a maximum flight time of about 3 hours. The rubber shock absorber system between the propeller and the frame helps reduce vibration during flight. The R-22 helicopter production process at Robinson Helicopter Company is carried out meticulously and professionally, ensuring the highest product quality. Materials such as aluminum, steel, and composites are strictly tested before processing. The propellers are pressed from aluminum alloy or composite according to standard molds. Anti-corrosion coating and load-bearing tests ensure that the propellers meet safety standards. The fuselage is reinforced with strong welds, ensuring load-bearing capacity. Pipes and wires are carefully installed inside the fuselage. The Lycoming engine is attached to the airframe with rubber shock absorber joints. The steering system is directly connected to the engine and propellers. The blades are secured to the rotor shaft with heavy-duty screws. Balance and precision testing to reduce vibration during operation. Controls and gauges are installed and tested. Seats, ventilation systems, and windows are installed. The fuselage is coated with anti-corrosion paint and can withstand harsh weather conditions. Each R-22 is individually serialized for management and warranty purposes. All systems are tested on the ground, including the engine, steering system, and fuel. RHC experts conduct flight tests to check performance, safety, and operability in various conditions. The Robinson R-22 helicopter is not only an ideal choice for flight training and civil operations, but also a testament to Robinson Helicopter Company's commitment to providing rock-solid air transport solutions. Knight Group is a global leader in electric motor technology, providing innovative and efficient solutions for a wide range of applications. Knight Group's automatic electric motors production line is a testament to the company's dedication to efficiency and precision. The line incorporates a range of advanced technologies to ensure the production of high-quality motors while minimizing human intervention. The production line utilizes automated material handling systems to efficiently transport components between different stages of the manufacturing process. This minimizes manual handling, reducing the risk of damage and improving overall efficiency. CNC machines are employed for precise machining of motor components, ensuring consistent quality and dimensional accuracy. Robotic arms and automated assembly stations are used to assemble motor components with high precision and speed. This reduces the risk of human error and improves production efficiency. Integrated quality control systems monitor the production process at various stages, ensuring that all motors meet stringent quality standards. Raw materials such as copper wire, steel laminations, and other components are inspected and prepared for the manufacturing process. Stator cores are manufactured using CNC machines, and copper windings are precisely wound and inserted into the stator slots. Rotor shafts are machined, and rotor laminations are stacked and secured to the shaft. Permanent magnets or windings are then added to the rotor, depending on the motor type. The stator and rotor are assembled into a complete motor unit, along with other components such as bearings, fans, and end caps. Completed motors undergo rigorous testing to ensure they meet performance specifications and quality standards. Motors that pass inspection are packaged for shipment to customers around the world. NIDE Group's commitment to advanced manufacturing technologies and rigorous quality control processes ensures the production of high-quality, reliable electric motors that meet the demanding requirements of various industries. By continuously investing in innovation and improvement, NIDE Group remains at the forefront of electric motor technology. Klingerberg is one of the world's leading manufacturers of gears and transmission solutions. With over a century of manufacturing experience, Klingerberg is renowned for its precision gears, which are used in a wide range of industries such as aerospace, automotive, renewable energy, and machinery manufacturing. Gears are manufactured from high-quality alloy steels, which undergo rigorous heat treatment to increase hardness, wear resistance, and durability. Some gears are coated with special surface layers, such as nitrition or DLC, diamond-like carbon coating, which improve load-carrying capacity and corrosion resistance. Gears are manufactured on micrometer precision CNC machines, meeting international quality standards such as DIN, AGMA, and ISO. In particular, Klingelberg is capable of producing gears with extremely tight tolerances, ensuring smooth and efficient operation. Klingelberg uses specialized testing and measuring equipment to check all parameters of gears, including geometrical accuracy, tooth profile, and surface roughness. Measuring machines such as the P-Series not only measure accurately, but also analyze the performance of gears under real-world conditions. With optimized design and high-quality materials, Klingelberg's gears can withstand high loads and high torques without deformation. Gears undergo processes such as hardening, carburizing, or nit-writing to increase durability and load-bearing capacity. After heat treatment, gears are precisely ground by specialized machines to achieve standard tooth profiles and smooth surfaces. Using 3D measuring systems and specialized measuring equipment from Klingelberg to check each gear before leaving the factory, Klingelberg gears are used in the transmission systems of aircraft engines and propeller control mechanisms, integrated in gearboxes, differential systems, and steering mechanisms that require high durability and precision. For more information, Sweet Drilling Tools is a notable name in the field of rock drilling tool manufacturing. With many years of experience in modern technology, the company provides a wide range of high-quality products to meet the diverse needs of rock drilling projects. The rock drilling tool manufacturing process at SVE Drilling Tools is a complex process requiring a harmonious combination of high technology and strict quality control, and rapidly developing and performing glass assembly, technical and confidently manufactured glasses, and ensure brightness and sharpness purchase-specific design for each step. Raw materials are surface-treated to remove impurities, increase adhesion, and prepare for the next stages. The raw materials are machined with modern CNC machines to create precise shapes and sizes for each part of the drilling tool. The parts are heat-pressed to create a tight bond between the material layers, enhancing the durability and service life of the tool. The machined parts are thoroughly inspected for size, shape, and hardness to ensure they meet quality standards. The parts are assembled into a complete drilling tool according to the engineering design. The drilling tool is plated with different layers of materials, such as diamond, carbide, to increase hardness, wear resistance, and improve drilling performance. Some types of drilling tools are coated with lubricant layers to reduce friction, increase service life, and improve working efficiency. The completed drilling tool is thoroughly inspected for size, shape, and accuracy. The drilling tool is tested under actual working conditions to evaluate durability, drilling performance, and service life. SVE Drilling Tools continuously invests in research and development to improve product quality and meet the increasing demands of the market.